Hello everyone, my name is Rohafza. There we go. And I'm going to tell you about the digitization of scent. It's what our company does, Altered Carbon. In the last month, we've been to the United Nations and we won 2 awards there for food loss in agriculture and the Innovator of the Year award. And in the next 6 months, we're going to launch the newest model for airborne diseases inside hospitals. So that's coming up in the next 6 months. What I'm going to talk to you about in the next 40 minutes is about how we changed and turned our chip, which is a little chip about that big, around 6 millimeters by 6 millimeters, with hundreds of receptors on it, just like your nose. And it works in the same way as your nose does, so it can smell, and we have an AI platform that's like the brain. It can be trained, just like when you were a child and someone showed you popcorn for the first time when you were little, and that created a memory in your brain of what that is. That's kind of what we do at Altered Carbon. We train something, we retrain it, we show it again and again until it learns. Majority of our stuff is from food loss to animal welfare to human and social care. So scent and memories is really important. One of my childhood memories is of my grandfather, actually. So he was a really strong person. He used to work in an orchard every day until about 90 years old. And he was up in trees and we kept telling him to get down. But this memory is really strong. And I can remember the smell and some of the tastes of fruit and the things he brought down. But the older he got, the more, around 94, 95, he started to just lose all recollection of all of his family. So he got Alzheimer's. We didn't know that at the time until it got later and later, until he couldn't even determine who his wife was. And it was really sad, but this really strong person that I knew as a figure just completely deteriorated. And so my interest of what we do in figuring out how scent works actually came from that understanding. So the person who really guided me was, funny enough, Michael J. Fox from Back to the Future. You remember the movies? He's a really amazing person. So when he started to get older, he started to realize he had Parkinson's. So it's a brain degenerative disease. And he started this foundation where he said, basically, in a few years, I won't even realize that I have all of this money. So he funded all of it into the Michael J. Fox Foundation to figure out what caused it, what was happening, and if he could help people. The one thing he figured out was around 100% of people that get Alzheimer's, Parkinson's, and other dementia lose their sense of smell 10 years before. So it's a really interesting thing. So he funded 2 billion into this project, and he figured this out, and his project is really amazing. It's now putting these little test strips into majority of doctor surgeries around the world, where if you get to around 60, 50, 60, they will actually give you these little strips where it's like the perfume strips. You smell them, and then they know if you can't smell that, then you're starting on the trail to getting these brain degenerative diseases. And if you are, they can stop it. As long as your brain hasn't started degenerating, they can actually catch it and do something about it. When it's already happened, there's no way of turning that back at the moment. So catching it early is the best thing you can do. So this is just an overview of what his work is. It's really amazing, and this is what inspired me to understand the next step. And the ability to smell is one of the most powerful. If you look at yourself on a photo from where you were young, it won't trigger as much memory as something like cut grass or freshly baked bread or the smell of your mother's cooking oil. It's one of the most powerful senses we have, and it's something that wasn't able to actually be researched on, because it's the only sense you can't do off the post-mortem. You have to do when people are alive. It's a very hard bit of research to do. So he did the most amazing bit of work just getting that across the line, and that created a lot of what my company does in the interest side and just overall. So this 100% of people that lose their sense of smell is what we wanted to solve when we first started our company. There's a lot of work that goes into that, and it's probably about 5 years away, but we have to start somewhere. So our chip is tiny and it can fit anywhere. We're working with companies to replicate that into scents and then mirror that into the brain. So similar to like how Neuralink works. So we can connect it up to something that connects to the brain and work out that scenario. But we're starting in an earlier process. So this is our company.
Altered Carbon has been built to enable machines to detect scent. Scent is just a cocktail of chemical compounds, and we've built a multi-array sensor using evolved graphene which can detect these compounds.
We develop 2 types of sensor technology. We've got our traditional sensor that detects a single gas, but we also have what is an electronic nose, and this is about detecting scents. So scents are complex mixtures of gases that require a really quite sophisticated analysis to understand what's happening. If you think about your nose, it's got many, many receptors and lots of complex processing to actually figure out what you're sensing. And really, that's just a complex mixture of gases. So Altered Carbon has developed an array of sensors that essentially mimics the biological nose.
When our sensors are exposed to different compounds, they create different patterns. These patterns we call digital fingerprints. This collection of digital fingerprints becomes our scent library. And the more scents we have, the better able our sensor is to detect a wide range of compounds from a single source of information.
Currently, technology can see, hear and touch. Altered Carbon is here to enable it to detect scent.
So a mobile phone has cameras, mobile phone has speakers, touch, everything nowadays. What we do is give it a new peripheral for robotics to be able to do new things.
This allows a new stream of information that has previously been untapped, enabling us to learn so much more about our world.
So we've worked really hard to make sure that the technology that we're bringing to market doesn't require us to reinvent the wheel at every stage. So we're taking advantage of existing manufacturing lines, existing technologies, and existing understanding to produce extremely high volume sensors. And this is one of the things that allows us not only to bring this new technology to market effectively, but also do it in a way that is extremely cost effective to our end users.
Chemical sensing has always been difficult. There is a lot of external variables that you have to deal with. Simplifying this process means we can understand more about our world, from being able to detect oil leaks to when food's going off, to even detecting fires before they start. All of these things will enable us to do more with our technology.
The blood sugar sensor revolutionized the medical field. It's saved countless lives and has made immense commercial success. It's a revolution in sensor technology.
So this is for you to see that I didn't do this alone. That's the rest of our team who all helped create this piece of technology. And it's amazing. So we've come a long way from the start. So we started off in the Bristol Robotics Laboratory, which is one of the biggest robotics laboratories, right, in Europe. And we started off doing internships there, and we actually tried to build batteries out of graphene. That's where we first came from. And it was for the MOD, so the military, and we failed really horribly there. We couldn't build these batteries, but what we built by accident was a single receptor. So we saw that someone was spraying deodorant. Funny enough, it was Lynx. You may call it something else here, but we were spraying Lynx across the room, and it actually picked up a trigger. So it was a resistive-based sensor that we've created, and it's like a chemi-resistor, if anyone knows how that works. And each one of them is unique. So we have a 10-element array at the moment. We have a bigger 20-element and a 50-element array that we're now producing. Soon it's going to be 1,000 in a tiny space of a centimetre by centimetre. The closer we can get to how many of a nose have, which is going to be really hard and it'll take us years, is the closest we'll get to an actual nose. So our progress started by this complete accident, and then we understood what we could do with machine learning. So pattern recognition, forest trees and other things, understanding how we can collect that data, show it examples of what we want to detect, and then kind of replicate that in the real world. Because just because you can do a lab test on a scenario doesn't mean that scenario will work in the real world. Just imagine you guys in this room. If one of you was ill, I could test that in a lab and go, I want to detect, let's say MRSA or something like that, which we're actually testing for at the moment inside hospitals. If I did it in a lab, it would be a small environment with not that much contamination. But then if I did it in this room, it would be really hard to pick out. So this is what we're working on in real physical environments. So we've built an actual, in Bristol where we work, we've built a room that's exactly like a GP service. We've built a room that's exactly like a home. And it has a bedroom, a bathroom and everything. And all of our testing actually happens in the real world because you need real world data to do all of this process. So what I'm describing to you is the journey that we took to get there. So some of our work is the digitization of scent, and we work a lot in disease detection in fruits and vegetables. So we're working with Berry World's, one of the biggest berry producers in the UK, detecting fungal, like grey mold. We're detecting black mold inside homes at the moment, which is a really interesting one. So all of it is to optimize storage and increase yields in that process. these are some of the food ones. So these are ones we presented at the United Nations the other week that we won the competition for. So we're preventing these losses, and these are some of the companies we're actually working with right now to do these. So those are the type of molds, those are the type of infections that potatoes get and other ones. And in high humidity environments, these start spreading wildly. So the only thing they need is a sensor to tell them that if you have storage of containers inside a warehouse, number 1 needs to go out to be sold, or number 5, or number 59. That changes a massive food loss waste if you can just tell them that this needs to go to this store, which sells more food. So that's what we do with our unique sensor, and we can optimize it so we can change it by chemistry. A lot of our work is in automation and chemistry, so it's not like other sensors where you're stuck with what you have. Day by day, we constantly iterate the chemistry and we build new sensors. So we built things that are more susceptible to infections, more susceptible to fungal spores or other things. So it's a really malleable tool that we have, and you can use it to build other things from that. So we can expand our array, or we can build new arrays for different clients, and we can work out this scenario. I don't think we need that. Sorry, I want to change it. Fine, it won't let me stop it, but we'll see what happens after. So this is the early mold piece of work we did. A lot of it is on distribution. This is the problem we solved. We realized that unfortunately when it goes into stores, a lot of people don't care. When it goes into homes, a lot of people don't care. We realized that, which was a hard truth we had to learn, because that's the first place we built the product for. So you have to interview your customers and understand what they really want instead of just building. And then we understood the only place we can actually take effect is the 40% of loss that happens in storage and growth. And this is where we've attached our sensors, and this is where we're working out how to deploy. Can I go next? So the opportunity is to enhance the ability using this graphene technology. It's really important. It's unlike other solutions. It's really scalable because it's printed. So we use inkjet methods to print it. We can print reels of it, and they're really, they're solid state, so they don't become affected by many poisons or other things that other sensors do. We've made over 300 candidates, and it's now in a month or two it'll expand with automation into thousands of different candidates for different sensors. And we're now working with everyone around the world to try and automate this process to test. Because what you have to do is show it something 1,000 times. And that 1,000 times, if you show it a good thing and a bad thing, it will learn. But you need to also show it like a cluttered environment like this and go, this is also the bad piece of fruit in this big, massive environment. If you do that well, then the model becomes really accurate. And I'll talk about some of the models we built later. So our mission is really simple. It's transforming how people interact with these devices. One of the funny things is that we're working with is an artist actually in London who wants to give emotion out with his paintings. And one of the things we're doing is, so we're cloning out how smells look in one place and then delivering it out on the other side. So he may want to fingerprint his mum's cooking, and then in that art gallery, when he's displaying his work, it will give out that emotion where people will be drawn back to that environment and moment, which is really interesting work. But those are some of the ones that are in the background that we're doing. And of course, this is all for IoT sensors, devices that can be deployed easily. So it has to be, our rule was, it has to be cost effective, has to be deployable. Loads of our other people that are building this technology, their sensors like thousands of pounds. So it means normal people can't afford them. You can't place them anywhere. Our goal was mass deployability. Everyone should own it, and it should be cost effective enough for everyone to have it. So our vision is to create this new dimension of data, which is really important. It has to be accessible. There is bad sides to it as well. I like to speak about that because you always have to talk about the ethics of what you build. And at the start, when I built this, we didn't think there was any ethical problems, but there is, and we're now drawing it on. So one of the people that we have on our board is the professor for robotics ethics, and he's helping us understand what we created and what we're going to do with it. So one of the scenarios was, I was like, it's a scent, it's something that smells, it can't do anything bad, but then you realize what a sniffer dog can do. So if you imagine cameras can look right in front of you, yeah? This can go around the corner. This can trail things for miles. This can, look at stuff from here to miles down the road if you want to do. Same as a sniffer nog. So there are bad sides to it, and we need to find out how to use it in a wise way and not make it into a tool. That's the thing we're discussing at the moment with the professor of ethics, but that's the thing we want to know, is how do we use it in the best way. It's funny with any technology, it's like a knife. You can cook someone a meal, or someone can go and stab someone with it. So you have to find out how you can use it, how it can be used for bad, and maybe put safeguards in place for those things not to be used. Timing is everything for us at the moment. So with the advancement of graphene is really important. We wouldn't have been able to do this. We use a lot of other 2D materials, but graphene was what we started with. It's an amazing scaffolding. And this scaffolding allows us to place anything on top and build whatever we want around it. It's like a clean shelf that basically a clean shelf that we can put anything on top of it, build around it, and then modify to whatever we need. So it's really malleable. And then AI has helped us process that data because it floods out tons and tons of data. We have hundreds of elements. This data comes out and we have to do something with it. So AI, and then market readiness. Companies before have tried to do e-noses and they've all failed. So it gave that name a bad name. That's why we even use digital noses. Now we've had to change what we use. And it was all because of this guy. So if you guys don't know him, these two actually. So they actually came up with graphene by using Scotch tape on graphite. It was really interesting too. And their story is really amazing. So when they were in studying, they found out that, well, the actual next video is really interesting, but they found out about superconductivity first, and then years later, 4 years after, is when they found out about graphene. They used the same process and they made chips out of it and everything else. Our work is literally based on some of the research they did, and it's really amazing. We always say we did science with hammer and nails, and it's one of the best ways to explain it. And now we're going to the more scientific side, but you had to do that to progress really fast. For them, they used Scotch tape. They could have used a hardcore scientific method. They didn't. They used a really simple, cost-effective tool to find out what it did. And then now they're using more enhanced tools to get further and further. And that's really important in the first research stage or a startup stage, which I'll say. You need to move quickly. You need to move fast. This is what they did, which is amazing. So they found out they can use superconductivity to levitate liquids and bolts. And this is what they won the Nobel Peace Prize for.
Can you look? Because I like to show this is the magnet, which is beyond. If you have a look here, this is. Yeah, 5000 is a jump.
Yeah, this is it. Yeah, there you go. Leave it. So that was me. I tried. Yes. Good.
Oh, great.
Good. This is a nice.
Yeah, this is it.
Actually, don't walk, don't touch anything, please.
I recommend going and watching their work later, because this is what defined what graphene was. And they started levitating everything. So they firstly tried one liquid, and then they were like, why don't we do animals? Which is the most ridiculous step you can take from just a liquid. And this is what has made things like the trains that levitate. This is what's progressed that. I think that's why they did Nobel Peace Prize. This is just a bit of coral that they levitated.
There is no problem with putting a man, to force a man by this magnetic levitation to fly in the air. So technically, we can do it with you without any problems. We put it here. Let's put it here.
So he jumped very fast into liquids, animals, and then humans levitation, which is absolutely hilarious. But this is where we got the inspiration from. This is where the graphene, he found graphene. He was looking for new materials, and this is where the discovery of new materials is really important. Now there's, I think, nearly hundreds of different 2D materials that now have come out that we can use for this progression of new sensor. So the era of new sensors is very interesting, and they're amazing. So things like pulse sensors, things like magnetic sensors, everything else can now be made really thin, really tiny, and really effective and really cost effective, because they can be all printed. Instead of having high-end pieces of equipment making them, you can make them in the most cost-effective way. And they did it with tape, sellotape, and that's where the process started. So our device, which I'll show you here, and we'll go on to it in a second, but It basically does real-time detection, and we've patented it, but that's nothing for this session. It's just in there. And we have a scalable piece of hardware. So it's actually, we work with developers. We work with developers all around the world. We build the chip, and we've built a base hardware to show people what it does. But our whole concept is find partners, work with them, and then build on top. So they're the ones who build their end product. We just show them what our chip and AI platform does, and that's the main goal of it. And it kind of, the more we work with customers, the more we learn about what needs to be done and the process of development, and combining this cost-effective, robust, and scalable solution into something that everyone can use, not just people with loads of money. That's the main goal in what we're doing. I don't like another video. Thank you. No. Can I stop it? Apparently not. When a video plays, you can't stop it at all. There you go. I'll just do that. End this very quickly. That's just much easier. I don't want this video to play. So then I can show you the device, which is actually the more interesting part. How do I full screen this again? No. Fine. We don't get full screen anymore. So the whole concept is we built this little device. It's little, tiny, it has a year life of battery in it, and it has a little button at the front. So what this does simply is anytime an event happens that you want to record, you just press a button. On our platform and our data, it just creates a window of that structured data. So we've given this to nurses inside hospitals in America. There's 3 hospitals trialing this. They're in elderly care homes inside an armband, actually, that's on patients. And then there's also mothers with prams, which is a really odd one, that they're really good data taggers. Honestly, anything that happens, a car drives past with diesel, they'll tag that data for you. And we have a mobile app as well. So the mobile app, when you press this, later it will come up with a trigger saying, what was that event, and tell us what that event was. So we've made it so simple for people to use. So every time I do this, it records that environment for that second, whatever's happening around there. Really simple, really easy. The easier you make something like this, the more people will use it and the better it becomes. And so we've gone to how simple can we make it for someone to not have to do any work to collect data, because that's the hardest part. We need a lot of data. And our whole goal is to build a library of scent, which is, this is what our platform does. We're building digital signatures for every scent and combination of scents. So in the future, we can build up enough of this library that it becomes something where it can guess what the next one is. So that's what our goal is. And each one of these clicks just records that window of data for you and collects in our platform. So this is what our platform looks like. If I go, no, you don't need to. It's basically a really easy to create scenario. So you have data sets, you have the structure of what the data looks like, and hopefully he goes to the next bit. So slowly though. He's crawling, it's fine. But these data sets, we have loads of them. This is just a private account. And what we do is record for each client. We have hundreds of clients at the moment we're working with all around the world. And each of them is structured in a way where we have basically 20 to 50 elements that they can select from, and they tag that data, and it can carry on. So you have fleets as well. So fleets of sensors could be all around this room, and one of them gets tagged, all of them gets tagged. Make it easy for people. And each structure of data is that simple. So you draw a line and you tell it what that line was. The simpler, the better. Make it easy, make it usable, and then that generates AI models at the end. So we say, what did you want to see? So you tag what you want to see, but you also have to tag what you don't want to see, which is really valuable. And at the end, all of it gets inputted to the model, and you go, what is the scenario I'm looking for, and how can we make this better? So some of the healthcare side that we're working with is at the moment, we've gotten models for C. diff, Staphylococcus, an early model for COVID, but that's old. One of our early wound infection models was for the NHS, working out how you can detect wound infection before even the nurses can, so without having to take off a bandage. So we did that on 3 different bacterial colonies, which is one was Staphylococcus, yeah, very interesting. And diabetes is one with, diabetes is one with screening at the moment, and that's a hard one, but you can do that, yeah. So anything a dog can do, we can do. We just need a lot of training to do it. And then we fingerprint these, and we validate these with labs that aren't us. So we had to have a scenario where it was us not validating the models. We send it to external people, like NHS and other people, to validate our models. They tell us what the accuracy was, and then we retrain, and then go around. We do not validate our own models, because that's a bad step to take. We can set it to whatever we want. Can I go next? But this process grows, and there's so this is what our model is really. So it's the discovery stage with partners. We have partners that constantly join our platform. At the moment, there's a massive waiting list, but we have constant people joining, and they fill out a form saying what they want to do, and we judge it based on how good the idea is. And the important thing is it has to reduce either food loss, or it has to basically save people's lives. So those are our two targets to hit. So we didn't want it to go into oil and gas or other things because we thought those areas aren't for us at the moment. In the future, the technology definitely will, and people can use it. So people will train it to that. But we thought the best thing to attack is reducing food waste and basically early disease detection. So we're not ever fully diagnosing someone. We're just telling them they should go and get tested. And that's why it's easier for us to be in elderly care homes, so before a hospital, and warn people to go and get a test, because that's at the moment the biggest struggle for the majority of the medical services around the world, people not going and getting tested. So the quicker they go, the less time they spend in hospital, and the more that helps in the future. Because those bigger tests have already been built. They're already there. Mass gas chromatography, SIFT, MS, all of those things are already there to be tested. We don't want to replace them, and we don't want to replace the doctors and nurses. We just want to add to them. So yeah, with our Sense Studio, our graphene chip, which is that tiny chip there, and it's now even smaller and even more elements on it. We built this training node. So there's two devices. One is the more powerful one with a battery system, and all of it was developers' tools before, but we built it from the ground up. The next stage of what we're doing, we're integrating this into a mobile phone, so everyone can carry it around. And then our library of Sense, people can use in a way where it will just be like you developing an app for Apple. You can access the library, access the chip, and then go, I want to build this app out of it. And using the API, you can easily output that into whatever you want. So you may want to build air quality data around the city. That's easy. You can do that with people's developer phone, simply put, and then you can go across that. This will hopefully change how people look at it, and hopefully will be integrated then into a real mobile phone, not just as an external plugin. It'll be actually on the back of every phone, because think about it, they have gyroscopes, GPS, everything, sound, microphones, hearing, everything. So this would be the new Sense that adds on so many abilities to a mobile phone and mobile device going forward. And this is some of the validation we've gone over the years. We started off with a single element, as I said, and this is what we did. We did a project with Toshiba, Umbrella Project, MPL and UE, which is the University of West England, but we all got degrees from. And then the first one was on air quality. So it was NO2 around the city. We have around 300 units at the moment plotted around Bristol. So these massive units called the Umbrella Project with 5G gateways are plotted around, and it's been 4.5 years now. They've been running, taking air quality data, and they've been working to help the city kind of better perform, because they used to have 3 main base stations all around the city to take this air quality data, but all of them, all the time, 2 of them were down. We didn't understand why, so we wanted to solve the problem. So we said, why don't we partner with someone and put these out everywhere? And now that in the city of Bristol, you can have a better map. You can have a more accurate map of where the pollution is, where cars are, and how you can build maybe a map that layers on top of the Google Maps or something like that, that you can layer on top to know what your route should be as a cyclist, potentially. Where you want to go, you may not want to go into high traffic areas. We did a massive project into carbon monoxide. This was also part of the other thing, part of UE's work. So carbon monoxide is something that affects loads of people. So we installed these on top of cookers, which is a really interesting project. We could tell if things were burning before they started. So like if your steak was about to go bad, or if your toast was about to burn before it burnt, you can just trigger an off button. Really simple, really effective. This was in containers, massive containers with loads of bananas with MISC, and a project that grew quite big was to just understand where bananas was, what scale, so detecting ethylene, and this was all on our single gas view that we did. So this was years ago that we studied these, but all of them work, all of them models that people can use now to develop their own tools. If you want to tell what maybe a banana burning, you could do that with 2 models. So we've made the ability to clash models together to see what happens, which is really interesting. This is the stuff about wound care. So this is a study into the 3 bacterial colonies that are majority times on wounds and cause infections. So biofilms are bacterial colonies that then spread, create colonies, and that's what infects. If they're on top of your skin all the time and they're completely fine and happy. They're really good for you. But if they get into a cut is when they cause infections. And this is a study that we did with the National Institute for Biofilms, National Biofilms Innovation Centre, the NHS, which was the NHS Children's Burn Victim Hospital. So they took samples off of children that had been, unfortunately, in fires and accidents, and they brought it to our labs, and we managed to test these profiles to find these biofilms and then actually sample them on our sensors and figure out if we could detect them. And we got a signature of all of them, which was amazing. So this study is still continuing because it's so massive. And of course, the NHS is very particular on what they allow into the system. So we're still trialing this to see when it goes into the system. So it'll be something like this, but tinier. They'll fit on top of bandages, stuff like that. And it will just tell them when they need to be changed or when they need antibiotics and stuff like that. Because majority of infections actually happen when someone changes a bandage, which is funny. So they have to change the bandage often, but the infections happen when they change a bandage. So it's kind of it's a problem there. So this is our work into C. diff. This is our newest client that we've been working for years. So we got a 97% accuracy on the model that is for hospital-based C. diff infections. So C. diff affects people that have Crohn's disease, that have anything like if they've been getting like cancer treatments, anything that lowers your immune system. C. diff will infect you so badly, and it's basically in hospitals, they have to quarantine whole areas. So the problem with them is at the moment, they spend about £3 million a year per hospital to quarantine people, payouts and everything like that. If they could detect it earlier, firstly, they wouldn't have to quarantine, and also they would know where it came from. So if you install these actually into care homes, one step back from the main problem, you would understand where it came from, who brought it in, and how you can resolve that problem. Instead of bringing them in, you could put them in a special ward and take care of them before they spread it into other people that could die from that. So a normal person may not die from it, but people with autoimmune diseases will die. And it's a very bad death because makes you expend your bowels, unfortunately. And so this is what we're working on. So we're going to install it into 3 hospitals in America within the next 6 months. And this will then trial our big use case for deployment in hospitals. But the nice thing is any other model we build, because all the devices get uploaded online, they just add on. So we then add on to the hospital. We go, now we've done one for wound infection. Do you want to add that onto your system? And they just update. And they just update again and again. So we're doing MRSA next. We're working on different progresses. So the nice thing is make an updatable system that's remotely done. So we don't have to change the hardware then. The hardware is the expensive part. We only have to update the models going forward. So this is just about us. So we have loads of patents on this technology, but that's not the interesting part. We've raised over 1.8 million, about 2 million in grants just to get to where we are. It's not cheap. We're now going for a much bigger round in a year. So we're going for a £20 million round because we want to profile everything. We want to profile as many scents as possible because diversifying means that then you can define anything in between it. So if we do all infectious diseases, then we can know what a cross-contamination between one and another is. So this profile will help us build these server rooms, massive data centers of smell that we're going to create. And this validation means that we've won multiple awards like the ST 500 award, Food Tech 500, sorry, the ST Industrial Innovator of the Year award, and the UN Food Forum, which should be FOA, Startup Innovator. So we won in the 2 categories of food loss and the overall award. And that's kind of our team. This is how we built it. Our loyal team, that's all of them have been with us in 8 years now, working together to build this technology. It's not, deep tech is hard. Sorry. It's difficult. You need the right people, and you need people that stay for the long run. It needs to have the team, and then you need senior members of staff. So these are some of the people that really helped us as the head of the BRL, our new investor, Suresh, who's a neurosurgeon, and he already has an app in the NHS that builds on top of that. So it's really interesting what we can do with our technology. And some of the people in hospitals and this area. So and some of our partners that we work with. So we're working with Google Cloud at the moment, NVIDIA and AWS, all trying to help us process our data and build on top of this. So we're all in their startup program. I think it's a good place to end because I have a sore throat and this is now the place. Thank you very much. Yes. Similar, yeah. So, yeah. Yes, yeah. So when you're, one of the most interesting things we learned, and I'll answer your question. One of the most interesting things we learned is actually if you have a partner, they've actually studied this. So for years, if you fall out of love suddenly with your partner and you don't know why, and then years later when that partner gets tested or you get tested, one of you was ill and you didn't know it. And your scent changes between you and your partner. It's so weird. And they did this study. You can actually look it up. I'll send everyone a link, or I don't know where I can put that. But it's a really interesting concept. And then they found this out. So when you get ill, your scent changes, your whole fingerprint biomarker changes, and you release different gases. So you can profile those. With diabetes, the way we looked at it was through more breath analysis. So we've built one of these versions, but that's replaceable. So it's like, if you imagine it's like a pregnancy test in a simple way, you breathe into it, it collects, it heats up the sample, and then we get an instant reaction, like a large burst of data on our sensor. So it's a once usable scenario, but it works really well. And then you have a more progressive, like long-term analysis that this happens. So we're doing that at the moment. Yes, it can be useful maintenance of someone as well, knowing when they're about to go into shock or something like that, definitely. But it needs work and it needs a partner to do it with. Any other questions? Go for it. Yeah, well, yeah, we don't sell them. We loan them out to people. There's a specific way because we maintain them ourselves. But yes, you can. You can go on our website right now. If I can't, it's actually at the bottom of that. So if you go on our website, you can actually request to loan it. The waiting list is quite high, but yes, you can. And when you get one, you get a pack of 3 of them because it's really important with data. You need to have 3 devices because you need to know if it works or if it doesn't, and you can only do that with 3. So it's really important to have something like that. You can loan them out from us, and then you can use our platform. So the API and everything is free access when you loan that out per month, and then you gain access to all of our systems, and then you get access to our base models as well. So we have an AI marketplace that we create. We actually partner with loads of developers where they can profile stuff for us as well. And then if anyone uses their model, they get paid. So we create a marketplace that people can create stuff for us. So we're having researchers, PhD students around the world that are really interested. So they loan out our piece of equipment, do research, and then they come back and upload their model. Someone else in a company already has our device and wants to use it. Simply, they just go download this onto my fleet. And then if it works, they pay the money gets divided between us and the person. So it's a really good method to grow this quickly. We need as much help and collaboration as possible to get this to everyone, realistically. Thank you. Cheers.